Presenting Astronova, an autonomous telescope mount system providing go-to capabilities to any generic type telescope, designed to empower astronomy enthusiasts, providing the ability to precisely locate and track celestial objects with an intuitive mobile app control. It consists of three primary subsystems: a custom designed RA axis representing Earth's right ascension, always aligning the mount to the polar axis, hence the Earth's rotation always providing a horizontal pan, whereas a DES axis representing Earth's declination axis, controlling the vertical tilt to accurately align the telescope to different celestial objects. The modularity of the mount, on the other hand, comes with a custom designed Arca Swiss rail mount. This industry standard quick release rail mount allows for fast, secure, and stable attachment of various telescope types with little to no custom fitting required. It ensures a universal mounting interface offering flexibility for users who own or plan to use multiple telescope configurations.
Right ascension axis. Introducing the core of our precision engineering system. We begin with a customized pinion shaft, the heart of rotational motion precision machine for optimal strength and balance. Power is intelligently routed through a compact and efficient power distribution block, ensuring clean and controlled voltage delivery to every module. A high tolerance shaft coupler guarantees secure torque transfer between components, minimizing backlash and vibration. There is no ordinary gear. Our custom designed worm gear delivers smooth, controlled motion with high gear reduction for precision movement. Friction virtually eliminated thanks to precision bearings engineered for durability and long-term smooth performance.
The Astronova system is powered by a Raspberry Pi 3B, which serves as a central microcontroller managing all system logic and motor coordination. It is connected to a motor subassembly, which will be later on described in the declination axis section, and is securely fixed to the wall of the right ascension axis using a custom designed support bracket to ensure stability during its operation. The system is powered by a 6400 mAh LiPo battery, which is then connected to a power distribution block, which was shown earlier, providing portability and sufficient runtime for extended observation sessions. In addition to that, an LCD display is mounted on the body to provide real-time feedback such as status, coordinates, and the system diagnostics. At the base of the right ascension axis is a custom-designed Arca rail mount which ensures compatibility with a wide range of tripods, offering flexibility for setups across different environments. So now, zooming into the declination axis, Astronova features a robust mechanical support structure at the upper end of its mount, designed to stabilize the motor subassembly, which consists of a NEMA 17 stepper motor, a planetary gearbox, which we are citing here EG17G10 for torque multiplication, and a TB6600 stepper motor driver, a setup mirrored in the RA axis, which we explained earlier. This is all used to manage microstopping and ensure precise motion control. These components work together to accurately orient the telescope in response to users via the mobile app, or optionally manually override using a side switch. To further refine motion and ensure smooth, backlash-free operation, the declination axis incorporates herringbone gears, which their quiet and efficient meshing makes them ideal for continuous tracking applications, ensuring smooth torque transmission and reducing mechanical stress. Furthermore, a counterweight system is also integrated to balance the telescope's load and minimize strain on the motor, enhancing the overall mechanical stability and extending the system's longevity. Both the RA and the declination axis are equipped with limiting flags, which serves as physical constraints that define the safe range of motion for each axis. These are critical in preventing over-rotation, ensuring the safety of the mount during both automated and manual operation. So let's now take a look at the complete Astronova go-to mount system and observe how all these components function together in real time.
Doesn't that look fantastic? It was a beautiful view of our moon from our eye view using our mount. The first and foremost thing in any mount to look for astronomical observation is to polar align the mount, which means that the telescope should be aligned with the North Pole, which is Polaris. As you can see that we have given an LCD screen where there is a manual control toggle with different buttons as well as different Wi-Fi toggle options from which you can select. You can see we have a polar align button. Once you click the polar align button, it will give you a pop-up which will actually tell you that you have to move the motors manually from the toggle so that it can manually align correctly. And as soon as you press OK, the offset stores and the mount knows that where the Polaris is. So now, as the Polaris is assigned, we will now moving to the closest star.
As soon as you launch the application, you're prompted to grant location access. This ensures accurate positioning for real-time sky mapping. You can also see the location and the time on top of the screen when you open the app. And now moving on to the star catalog, you can scroll through the star catalog and there's a search functionality as well.
As you can see on the configuration panel, we have a lot of toggles including night mode, show constellation, show labels, and show grid lanes. We have also given options of homing, polar alignment. The polar alignment once clicked gives a prompt to confirm that it has been polar aligned, a stop button to stop any commands which are going through. Moving forward to the star catalog, we'll now move the star to a particular star called Antares with the azimuth and altitude values already given. When you click more info, it will also provide you information about the particular star you are looking to. As soon as you point telescope, the telescope moves and successfully locates the star.